So the next concept we need to touch on is what's called Lewis symbols. And what you're going to learn how to do is basically draw these and the information that we glean from drawing these diagrams and what we can learn about each individual atom because of their Lewis diagram. So the first thing that you need to kind of understand about, or a term that you need to understand in the bonding unit, is what's called the octet rule. Now the octet rule is simply that every atom on the periodic table wants to be stable. And we've established this in previous classes. But essentially it wants to be stable, or what I like to often refer to as kind of in its happy state. Atoms want to be stable, they want to be happy. And the way that they're stable is they have what's called a full octet. And the way that they have a full octet is that their valence shell, their outermost shell, is full of electrons. Now for most atoms, that's going to be 8 electrons. That's why we call this the octet rule, because 8, oct, mean the same thing. And so the octet rule for most atoms means, hey, that atom's going to have 8 electrons in its valence shell in order for it to be stable or happy. There's two atoms on the periodic table that have a full octet that don't have 8 electrons, and that's going to be hydrogen and helium. So hydrogen's valence shell can only hold 2 electrons. So you can see that this first valence shell only holds 2 electrons. So if it's its valence shell, which for hydrogen and helium are the only 2 atoms on the periodic table that have their valence shell being the first shell in that atom, then their valence shell is going to be full with only 2 electrons. Every other atom on the periodic table, its valence shell is going to have a minimum of 8 electrons for it to be full. For the purpose of this class, that's what we're just going to stick with. We're just going to stick with 8 electrons as the limit. Now, I've got some diagrams of just elements on the board here, and what we need to be good at doing is identifying how many valence electrons a particular atom has. So if we come to the periodic table, if you remember, just to kind of recap, we discussed that whatever group or family that an element sits in, that tells us how many valence electrons it has. And so if we're identifying on the periodic table group A, the taller part of the periodic table, this as group 1, group 2, group 3, 4, 5, 6, 7, 8. If I find an element that's in group 6, then that element's going to have 6 valence electrons. So you can see that hydrogen is in group 1, and so it's going to have 1 valence electron. Now for the bonding unit, that's all we care about. We don't care about any other electrons that it has underneath or in lower energy levels. All we care about are the valence electrons, because those are the ones that are available for bonding. They're the ones on the very outside. So when we're drawing Lewis symbols, all we're drawing are the valence electrons. Now, hydrogen's electrons, all of its electrons are its valence electrons. So that's kind of a unique thing about it. But when we draw Lewis symbols, what we're going to do is we're going to fill each what we call orbital first with 1 electron. Now again, the unique thing about hydrogen is because its first energy level is its valence energy level or energy shell. It only has 1 orbital, and so we can only put electrons in that 1 orbital. For all the others, you can see basically what we're doing to represent the orbitals is every symbol or every letter has sort of 4 sides, a top, a bottom, and a right and a left. And each side represents an orbital that atom has. And so boron, for example, sits in group 3 over here. It's got 3 valence electrons, and so I'm going to go 1, 2, 3, placing 1 electron in each orbital first. Now, because I've only got 3, I can't fill it all the way up, but if I come over here to carbon, you can see carbon has 4 valence electrons, and that's because it's in group 4 on the periodic table, and so then I fill in the electrons like this, 1, 2, 3, 4. And the reason I do that is because electrons are negative, and they don't like to be beside each other if they can help it. And so these electrons are going to choose to fill into empty orbitals first before they kind of pair up. Now, the interesting thing about electrons is that, again, remember, we can hold up to 8, and each of these orbitals holds 2 electrons. And so that's where we get that number 8 from, is that two electrons can go in this orbital, and in this one, and in this one, and in this one. And so there's space for them to go in there, but they like to fill in each empty orbital first before they start pairing themselves up. We take a look at nitrogen. Nitrogen is in group 5 on the periodic table, and so it's got 5 valence electrons. So again, the way that we fill this in is we go like this. 1, 2, 3, 4, and now I've got a 5th that's got to go in one of these orbitals that already has an electron in there. As long as all the other orbitals have at least one, now I can start to pair them up. And so I'm going to go like that. You can see that I've done this for oxygen as well. I've gone 1, 2, 3, 4, and then 5, 6. So you can see that there are 2 orbitals that each have 2 electrons in it, and 2 orbitals that each have 1 electron in it. And I've labeled these. These actually have meaning and perform and do different things based on the nature of what they are. So the electrons that are paired up, we call these guys lone pairs. They are not involved in bonding. They don't participate in bonding at all. The single electrons here, these guys are called bonding electrons, and they are obviously involved in bonding. That's why we call them bonding electrons. And then you can see again, I've labeled just what the orbital is, which is just sort of this circular place where electrons can exist, and each orbital can hold a maximum of 2. If I go over here to fluorine, again, same thing. This one is in group 7, so it's got 7 valence electrons, so I can go 1, 2, 3, 4, 5, 6, 7. And then if you look, neon's in group 8, so again, 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. And you can draw these fairly quickly. Now, something you need to be careful about is sometimes kids will want to just throw the electrons in, and they like to put them in pairs right off the bat. And so if we go with nitrogen, for example, that's got 5, you can see that kids sometimes would go like this. 1, 2, 3, 4, 5. And that's not right because it doesn't give us the correct number of bonding electrons and the correct number of lone pairs. Here, this diagram shows that nitrogen has 2 lone pairs and 1 bonding electron, when in fact, when we draw the diagram correctly, nitrogen has 3 bonding electrons and 1 lone pair. And that's going to affect our understanding of how nitrogen works and behaves when it does covalent bonding with other atoms.